What's up, everybody? I hope y'all are having a wonderful day. I'm excited for this episode. I hope y'all enjoy it because we added a new tool to the arsenal. And what we got to do today is put all the holes in these hooks. We got them all laid out here just like we left them. This is our template for our hook. So we're going to bore this hole. This isn't the size that there's drill bits for. We got to bore it to fit the pin. And we got to drill these holes. This is a 2 5/8 hole that hooks on top of the coupler. And these hooks all need it. So we're going to use our template and get all these holes cut. So let's head over there. We'll show you what we got and we'll get started. All right, so here it is. And what you're looking at is about a 1988 Bridgeport Series 1 mill. It's a milling machine. If you're not familiar, these things are a precision metalworking tool. Basically, you can flatten a piece of metal and get it, perfectly flat in all directions. You can drill holes in precise locations. You're going to see us use a boring head to enlarge a hole to a very precise dimension, down to the thousandth or even 10,000th. If you know what you're doing, which I really don't, but we're going to learn. This is an example, something I made. This isn't necessarily cool in and of itself. All this is going to be is a fixture plate. You can bolt to these T-slots, and then you can rest a piece of metal on here. That way you're not drilling into this table, because if you've used a drill press, they have a hole in the middle where your drill bit can go into. Since this table moves, it'll move the length of the table. A hole wouldn't do you any good. It would never be where you need it to be. So you could use that. And a couple of these are 1, 2, 3 blocks. These are precision ground to be exactly 1 inch by 2 inches by 3 inches within 2/10,000ths of an inch or something. So you could use 1 or 2 of these, set your plate on here, drill your holes in a pattern, and that's what this would be used for. But this thing was completely cut on this mill, and this dimension here is exactly 1 inch, as close as I could get to it, to match a 1, 2, 3 block. And you can just cut super close tolerances. You can make parts that fit together perfectly and slide, That's what a mill's used for. So this thing should really up our game, in certain circumstances a lot. So it's really awesome to have. So let's get started, show you a little bit of what it can do. So we've got a face mill loaded up in here. This is a 3-inch face mill. And if you remember from last week, we talked about this plate being used. Obviously, this was an old road plate, which is a plate that a construction company puts over a ditch to drive over so traffic can continue using the road. At any rate, we looked at how scarred up it was, and I decided we have the ability to smooth it back out. We might as well do it. This is carbide inserts on this face mill, and this is probably going to be pretty hard on them, but we're going to give it a whack anyway, see what happens. But we should be able to make this look like a machine finish again. So that's what we're going to try to do. This piece is a little bit bigger than what we have travel for, so we're going to have to move it to finish it all out. But that's all we got. So ideally, since this turns this way, you'd want to be coming onto this edge, leave you a nicer corner there, but we can't reach that end, so it's not really an option. But it's fine. Obviously not critical, it's just for looks, really. Just barely get off of it. So that'll do. Running off a variable frequency drive. The guy gave it to me with the machine. So you see me starting it with a little button over here, that's why. And it's underpowered. So if you start it with this, it trips it out. Bring it up until it touches. Touching. We'll zero the Z. So X is the travel of the table in this direction. The Y is the travel in this direction. Z is up and down, which we just did. So we went ahead and zeroed it. That's where the tool touched the metal. And some of these gouges are pretty deep. So we probably ought to take at least, I'm gonna say we probably need 40 thousandths at least. Probably more, but there's 40. And 5/10. Squirt a little cutting oil on here, because it's gonna need it. Get some in these holes. It's all kind of dirt and rust. All kind of things you probably shouldn't be cutting with carbide. There we go. Just a little bit left here to clean up when we turn it around to drill the holes. We got about 99% of all those gouges out. That is pretty nice.
Yep, the dirty old road plate, the brand new plate.
There's a few grooves in there from all the reclamping, but for what it is, be the nicest one ever. Okay, so now that we got it all cleaned up, we got 99% of the low spots out of it. We decided the best way to locate these holes is with the template itself, instead of trying to go off of measurements or whatever. We're just going to put an indicator in here, and we'll do a sweep of that hole and a sweep of this hole, and we'll get 0 marks on both of those, and then we can do our drilling, and we'll just have to repeat that for all the hooks. I had thought about getting a measurement between these two centers and trying to use it to repeat for the next ones, but that's not really going to work out the way I thought. So this is the way it's going to be done. Sweep this circle, get a center, and sweep that one, get a center, and then we'll drill them. And then we'll have to bore this one, of course. It'll be pretty hard to see what we're doing here, but we got a little test indicator in here. And we're just spinning the spindle around in a circle, like this. And we're kind of just getting these points because when I made these holes, I probably got in there with a grinding stone and I did a little hand filing and all sort of stuff. So the needle's all over the place, but we're getting a 0 around the top, which is the most critical part of this whole deal. We got a 0 back here, and then we're losing a few thousandths, but when you come back around here to the other side, there's a 0 again. It's bouncing around, and it ultimately comes back to 0. And then this hole runs out from being a hole to a straight line, but that should be more than close enough for what we need to do. And so that's what we're talking about with the indicating. We did the same thing with this hole. So this DRO can set 2 zeros, incremental and absolute. So we'll just switch it over here from absolute to incremental, and 0 to X, and 0 to Y. And now we have 2 0 points, and we can come back and drill them and then bore the pinhole. All right, so here's our cutter. It's a 2 5/8 annular cutter. This is what I used on those plates on the quick coupler. And these are pretty bad dudes. But you ain't gonna turn this into a drill press. I used a Winona valve guide grinding machine at Uncle Rudy's. There we go. One perfect 2 5/8 hole. Through 2 1-inch pieces of plate.
Yep.
They do a good job.
Smooth as a baby's bottom.
Yeah. From what I've seen, they're pretty close to right on size too. It ain't like a normal hole saw wobbling around all over the place. All right, so here's going to be our cutter for the pinhole. This is a 1 3/4 annular cutter. We decided we're going to go with 1.770 for our diameter. We're going to try that first. So this is 1 3/4, 1.750. That'll leave us 20 thousandths to take out of it, and then we'll try it with a pin. Try about 100 RPMs. May just clutch out. Clean up the bottom of the hole a little bit. All right, now it's time for the fun part. So what we have here is one premium Chinese boring head. And what this is going to do is it's going to let us put one of these little tools in here, and it'll spin off-centered. That's how you adjust the size of your hole. So with this thing, we could take that hole and make it literally any size we want, down to the 10,000th of an inch. Even metric, if you were inclined to do something crazy.
Yeah, who'd want to do that?
I don't know. But since this thing's Chinese, it probably cuts better metric holes than
Are
imperial
you sure it
holes.
even cuts imperial holes?
I don't know. We're going to find out. It might not. But we're going to get it chucked up. We'll pick a boring bar and see what we can do with it.
What's your speed need to be at for this?
Got me. I think that looks pretty good. We could probably go faster, but we're back on 1,000 per revolution. Looks like we're through the first plate, starting to cut the second one. Just about done. That's pretty quick.
Yeah.
That is just way too cool.
$1 million question. How many thousands did we get? Thousandths of a millimeter.
It's trying to kick out, see if it makes it. There we go. That's how it's supposed to work. Just beautiful. One little line in there where it may have picked up a chip and drug it, but other than that, very nice finish in that hole. So let's try our pin. Well, let's measure it first. See what we got. This is kind of tricky. Okay. $7.83. .6. All right. So we're back in the welding shop. Got our freshly machined parts here, and just laid the template on here. We'll just trace the outline with the template. It's got a little bit of a relief here for that round rod to slide into. Since it's machined, it ain't gonna draw very good with soapstone, so I'm gonna scribe it with this scribe, or awl. This is a scratch awl, I guess. Make sure it's good enough so I can see it.
This ain't what they used to be.
And nothing's what it used to be. This isn't a finished edge here, but at least I'll have a reference. I'll probably cut it all messed up anyway.
We haven't We haven't done any sanding or grinding, so we want to make sure we get some of that in.
Yep. All right. Let's whack this sucker. Something like that. I'm not gonna lie, I could hardly see that line. All right, so if you're wondering what this cylinder is sitting back here, well, this is something that we hadn't given a whole lot of thought to till today. But these forks are going to be hydraulic, so they can move in and out with hydraulics. You can unplug the coupler where those quick connects are and plug in the forks, and that'll work the forks also. But what that means for these brackets is we need to cut this section out. See, our rails weld right here. So we're going to have to cut this out in between the rails to make room for these cylinders. They're actually quite a bit bigger than that. It's going to take up a lot of this room. It's going to be pretty tight. There'll be two of them in here. And then the bottom rail weld here and the top one weld there. So we got to cut this out. So that's where they'll run. Of course, there'll only actually be one of the big part going through one of these hooks at any given time. This will be one big part, and actually it'll be one of just the rod, which is quite a bit smaller. That rod looks like just shy of 1.5 inches, 1 7/16 maybe. So there'll be a little more room than it appears. But we do need to come back some more and make room for hoses. Well, we got them all cleaned up. Got a nice hook here. We got the pocket for the cylinders cut out and cleaned up. Only one thing left to do. So let's go try one.
All right.
See if this bad boy fits. Well, it's pinned. It is still raising it up. Just have to wear in. Make another adjustment on the next one. But it's solid this way. Yeah. Not even bumping.
But I think that's going to do it for this episode, guys. We hope y'all enjoyed it. If you did, hit that like button. If you're not a subscriber, we'd appreciate you subscribe to the channel. Go down in the comments and type subscribe. That'll get you entered into our monthly giveaways. This month we're giving away a Husky 119-piece tool set. There'll be a link in the description. Check that out. But we appreciate y'all watching, and we'll catch y'all on the next one.